Hey, what's up? So it is finally time for the DWM video. My build is going to be public, you can go get it and use it if you want to, but what I want to spend this video doing is, first of all, breaking down the DWM source code in plain English, the most important parts of it, so that you can understand how this window manager actually functions. And then I want to explain how to patch it, if you're not familiar with how to patch it and how to resolve patch conflicts, etc., all of that sort of stuff. That will be the second half of this video. So let's go ahead and start looking at the source code. And I'm going to use my own build, but you could pretty much follow along with whatever build. The key stuff is still all going to be the same. So in terms of the files here, the most important file is dwm.c. This is where most of the code for the functionality of DWM is going to be. We have some functions split into other .c files. For example, drawing is going to be in drw.c. We also have this config.def.h header file. This is where the configuration goes for DWM. So if you're not familiar, you configure DWM and then you compile it. There's no configuration after you've compiled. So that goes in this file before you compile it. We have config.mk, we have a make file, but let's start looking at dwm.c because this is kind of the sort of infamous 2000 line file that is kind of intimidating if you don't know C. And you really don't need to understand every line or even every function in order to understand the key concepts of how DWM works. So as this is a C file, we're going to start at the bottom of the file, all the way at the bottom with this main function. C programs start with main. When we actually run the command dwm, it's going to first call this main function here. So for example, if I do dwm-v, that's going to print the version number. That's actually the first thing happening, right? We're gonna say, all right, if there's an argument on DWM and it's -v, print the version number and then kill the program. That's what die is, print and then kill, right? Or if there's an argument that's not -v, tell us how to use it, right? The next stuff going on here is all preparation in order to actually start DWM. So for example, like checking to see if another window manager is already running, right? If there's another window manager running, we don't want to start DWM, we would just want to quit, right? Then we have this setup function, which is going to initialize everything we need to actually start DWM. This is going to handle a bunch of init and x11 stuff. The most important part to understand of this function is at the bottom here. We have this event masks, and this is actually the key concept to understand how DWM works. Okay, so you have an event that happens, an x11 event. DWM is going to listen for that event, and then once DWM realizes, okay, this event happened, I need to send it to this particular function so it can deal with that event. So what is an event, you might ask? For example, a keyboard press, right? If I press mod and enter keys, that's opening up my terminal here, but the first thing that really happened is, well, I pressed the keys, x11 says there was a keyboard press event, DWM said, okay, I know how to handle that, let's call this key press function, right? And other examples of x11 events would be like mouse button press, or focus event, like focusing a different window, or like window goes full screen, that sort of thing. So where are these handled? These are in this run function, the next thing here. And this is the main event loop. This is, if main is the most important function, this is probably the second most important function, right? We're going to store any X event received under EV there. And then while DWM is running and handling the events, we're going to check to see if there is a handler for the event type. If there is, then call that handler and pass it the event data. So if there is a handler for a keyboard press, right, like when I press these keys, if there's a handler for that, then pass that handler the event data. So let's go look at where these handlers are listed out here. These are the x11 events. These are the functions that they are getting mapped to. So we've got key press to key press, right? x11 event of a key press is going to go to the key press function. And lo and behold, the last line of key press here is going to say, all right, if the pressed key matches a key bind, then call the function associated with that bind. So for example, if we're going to open an application here, that application being my terminal with, mod enter, that's going to be calling that particular function, right? And we have similar things if I go back to that handler section here, for like mouse button press, right? So if I click on tag 1 here, we're going over to tag 1, go back to tag 2, I clicked my left mouse button twice at, this particular pixel, whatever. If we go to this button press function, handles clickable areas on the bar. It's going to handle, this is what's going to happen when I press the mouse button, etc. Right? So let's go back down to this handler thing. You'll see the word client is used a lot throughout this file. Client pretty much just means window. So what you should probably know is there's a root window and then there's other windows on top of that window. So the root window is spanning both monitors here. It's not like my background picture itself, it's just you could kind of visualize in your head, this is a root window. And you have other windows, these are all, you know, on top of this window, they're children of the root window, okay? And these are all referred to as clients. This status bar window, it is a window itself, it's also a child of the root window, but it's not the same as these, you know, normal windows that I have spawned here, right? So what we can actually go through here is if we go to struct client here we are. I did not mean to select all that. Oops, struct client. There we go. So, for struct client, essentially you could just think of this as every window is going to have a bunch of properties, and these are the properties it has. Essentially, these are just values that are going to get stored in a single contiguous block of memory. That's what a struct is pretty much. Type def struct is just going to be a struct, but it's an alias for it pretty much. But anyways, so we've got various properties like the window title, okay, the current position of the window, the current and previous border widths of the window, the actual X11 window ID, etc. So every window we have this list of properties for it. So throughout this file, when we're talking about a client and we're going to have, you know, a pointer to a client, right? This is what's going on there. We have all of this data for the window. And actually I should mention with the tagging, so the way tagging is handled, every window is going to have a bit mask for the tag. So that way we know like what tag is this window currently on, right? So let's go back once again to that handler area. One of the other really important functions here is map request, right? Because in the logical order here of like I press a keybind and then it finally opens a window. So we talked about, you know, it needs to have that X11 key press event, and then DWM needs to call that key press function and say, all right, a key was pressed, open the application. But one of the next steps that we're going to go through is where do we actually put this window, right? Like I don't want it on this other monitor. I don't want it on tag 7. I want it right here on the left, actually. I want it, you know, this geometry. It needs the focus since it's the window that was just spawned, etc. So that's where map request comes in. Window is going to request a map. We're actually going to start calling a chain of more functions to handle all of those various things that I just said. So if a window is not already managed by DWM, we're going to call this manage function to start managing it. Manage is actually like right up here. And this is going to deal with a lot of different geometry stuff. It's going to call a bunch of other functions. Some of the important functions that it's calling are attach. So we want to attach it to the monitor's client list. Every monitor is going to have a list of windows currently on it, right? So if I, you know, open a bunch of windows here, these are all in a linked client list for this particular monitor. Say this is monitor 0. These are on monitor 0's client list. We also have a stack. So if you don't understand how a window stack works for a tiling window manager, essentially, let me put this actually in tiling mode so you can really understand it. This window that I've just opened here, let me put like something in this window so you can see it. This right now would be referred to as the master window. This would be referred to as the stack of windows. If I spawn a new master window, that previous window got shoved into the top of the stack, and every other window in the stack got shoved down one. So if I continue to open windows, they're all getting shoved down one by one. That's essentially how the stacking logic works. Okay, so we need to attach the window to the monitor's client list. We need to add it to the stack in the right place. That's what this function's going to do. And we also need to recalculate everything based on the layout, because there's a few different layouts in DWM. This tiling mode is the default layout. In my build, I have a couple other layouts installed, like this spiraling layout. It's gonna Fibonacci spiral there. There's also a dwindle mode layout, right? There's a few different layouts. You can get more than just that, but essentially we need to recalculate where all of these windows are going to go, their geometry, etc. So that's the arrange function. And if we go to this arrange function here, So this is actually what's going to deal with the real layout logic. And the layout logic is, by default, it's going to be actually in this file under tile at the end here. This is the base layout. I have it commented out because Vanity Gaps is actually handling my layout logic for my build, since Vanity Gaps being the patch that handles all of the window gaps, the gaps between the windows, it has to recalculate all of the layout stuff because there's now gaps there instead of just a plain window, right? So my layout logic is in this file. If we look at this tile layout down here, it's essentially just a bunch of calculation and math for figuring out where these windows go, their ratios, their scaling, etc. And that's the main stuff going on. At the end here, we're going to resize the master clients, we're going to resize the stack clients according to, these calculations with the various facts needed. There's also these other layouts up here in this file that's essentially same in concept, but just different calculation to result in a different window layout arrangement, right? So these are really the key things to understand with dwm.c and the source code here, right? The absolute key thing to understand is you have an x11 event that DWM is going to listen for. When it hears that x11 event, it's going to call the appropriate functions to deal with that event. That's the key principle of DWM. And once you understand that, it should be a lot easier to kind of figure out where patches are going to go. So for example, if you're dealing with patches that have to do like with the status bar, right? There's a function called drawBar. And most of these functions have pretty obvious names in terms of what they're dealing with, like kill client. Okay, that's going to kill the client. Load XRDB, that's going to load X resources database, etc. Right? These generally have like decently descriptive names. Anyway, so if you want to deal with like status bar logic, go to drawBar. And this is, going to deal with a bunch of stuff having to do with the status bar here. Or say you want to deal with like mouse button presses for like the status CMD patch, right? That's going to be under the button press function. If we go down to here, wherever it is, there it is, handles clickable areas on the bar. This is like right where my status CMD patch went into to handle that sort of stuff. So if you have this understanding of, okay, throughout this file, we have different areas that are going to handle these different types of events. Here's sort of the types of events that we have in this handler. If we go back to this handler section, here's a bunch of the types of events we have. That way you can sort of figure out, all right, if I'm trying to patch and there's a conflict in this patch, how am I going to resolve it? Where am I going to go in order to resolve it if I can't, find based on the line numbers in the context, right? So let's next look at the config.def.h file, which if you made it through that whole dwm.c explanation, then the rest of this video is going to be smooth sailing. Hopefully that was well stated and understandable, and I'm sure I made a mistake somewhere, so if anybody realized that I made a mistake, just leave a comment and I'll probably have a pinned comment with like any mistakes I've made. Anyway, so let's look at config.def.h here. So like I was saying, this is where all of your configuration goes before you actually build DWM. A lot of this file is very self-explanatory, to be honest, and in my own build, I did add the patch versions I have with a description of each patch. Do be aware, I've kind of changed some things in the patch code for some of these patches, so you might not want to just try to like directly unpatch something, but if you're comfortable with it, you feel free to go through and modify whatever. Anyways, so we've got a bunch of static variable declarations. A lot of these are going to be 1 or 0 to just, this is self-explanatory, right? Like 0 means no status bar. All right, if we set this to 0, no more status bar, right? These are just going to be numbers for gap pixels, etc. We've got fonts, we've got colors used if XRDB is not loaded. I'm using the XRDB patch, which is for X resources database, which is what allows me to integrate with the PyWall colors, i.e. deriving the colors from the wallpaper here. I do have some information on the README for if you want to set that up. It does require some extra setup. If you don't like my way of doing it, there's also other ways of doing it, so you can look at PyWall 16's wiki if you want to there. Anyways, so we've got the default colors, we've got the color scheme set up there, we've got the literal characters for the tags up here. We have window rules, and this is pretty useful depending on your workflow. So what window rules allow you to do is, say you always use your browser in tag 3, you always use your terminals in tag 2, you always use your music player in tag 7, etc, etc. You can set up for a specific window class, so for example, like a class of Firefox, right? That's always going to go to tag 3. you can set that up there. So that way if you spawn Firefox from tag 1, it'll automatically go to tag 3, right? So that's just, you know, depending on your workflow, right? For these glyphs here, you will need a patched font if you want to use these from my build, or you can just replace them with normal characters. And then we have all of our key definitions for our keybinds here. And this is pretty simple. We just have mod key. In my build, it's the Windows key. In the default DWM, it's just Alt key. I would recommend use either Windows or Alt. You probably don't want to use Control. Then you have any masks on that mod key. So, for example, Shift mask being the Shift key. Then you have the key sim itself. Then you have the function, and then you have any parameters that are getting passed in. And that's all of these keybinds are like that. And at the bottom we have our mouse button bindings, so the thing for like clicking on the status bar, right? That's where all of these button bindings are going to be. I also have resized the gaps with scroll up, scroll down, with mod key, etc. So that's the config.def.h file, and those are really the key files to worry about when it comes to DWM. So let's talk about patching, and I should have a blank build of DWM here to patch on, I think. I wanted to go over specifically this XRDB patch because I know it's going to have an error that we'll need to resolve, so that way I can show you how to resolve errors with patches. But actually, a couple things first before we start patching. So first of all, I wanted to mention this program called Zephyr. It's well, as it says, a nested X server that runs as an X application. So if you're going to be doing development on really any window manager, and you want to be able to run that window manager separately from your actual environment here, so like if I'm, you know, coding here in NeoVim, but I don't want to have to completely refresh my entire window manager to test the changes, that's what Zephyr is for. It's really useful if you're going to be patching and working on DWM and you want to be constantly, you know, trying what you're doing as you're patching it, right? So I did want to point this out since it's just a helpful tool. And then I actually wanted to mention there is kind of a correct order in which you should apply patches. I should probably start by talking about what patches are, just in case you don't know. So patches are essentially lines of code that you're going to add or remove or replace that are going to modify the functionality of the files you already have. And they come in these .diff files, which literally means difference, and we'll look at what this file has in a second. But on the Sucklist site itself, there's, you know, like 100 patches for different features that you might want in DWM. Anyways, so the order in which you want to patch is generally from the most intense and intrusive patches first, down to the most isolated patches last. So, for example, like core functionality patches like gaps or layout logic or like per tag patch, you want to start with that. Then you can move to like appearance and drawing related patches. Then to like status bar stuff, so like the status bar toggle stuff. I've got some, you know, toggle patches here. You know, status CMD patch for the little clicking on the bar there. And then finally do like cosmetic patches or anything super isolated last. So an example of something super isolated is this restart sig patch, which is going to add the ability to refresh DWM after a recompile rather than completely quitting it. This is very isolated. This has like one thing that it does, so it could go last, right? So hopefully that gives you an idea of what order to patch in to try to avoid conflicts. But once you start having a bunch of patches, conflicts are kind of going to be unavoidable. Like with this many patches, I did have a bunch of conflicts that needed to be resolved. And what a patch conflict is when you're patching and you have this, actually I should probably just get this patch file and show you, since that would kind of explain it a little bit better here. So I can just wget that file and we can go ahead and look at what this diff file has in it. So, what a patch conflict is say I'm trying to patch this config.def.h file. These white lines here are saying this is the context around which we're going to patch, around these line numbers. These are the lines we're going to remove in red. These are the lines we're going to add in green. And by the way, I would recommend getting an editor with syntax highlighting to look at a diff file. It makes it a lot easier. But anyway, so we're going to remove these, we're going to add these. What a patch conflict is say these lines were already changed by another patch. Some other patch already changed these lines. So now when I try to go apply this patch, the command used to apply it is not going to be able to find these lines because say, you know, everything here was already changed and it's also at like line 500 instead of line 15. So now it doesn't know what to do. And this is mostly automated, like we do apply a patch with a command to do it. But if there's errors like that, then you have to go in and manually fix it. Okay, so hopefully that actually also explained what this diff file is. We just have lines to remove, lines to add. These are the lines surrounding it. This is the line number. This is the file. We're going to have this for a few different files. And generally you would use the patch command, which is literally for applying a diff file. That's honestly the way I've always done patches. But the sort of proper way of doing it is actually with git apply. So I'll show you, well, if you want to do it with patch, just patch and then back arrow and then just put the name of it. But the proper way being git apply, because git is going to track changes, meaning if you patch something and you mess it up, you can then revert it. It also makes it a little bit easier if you want to be prepared for DWM updating or a patch updating, but that happens so infrequently that I wouldn't really worry about updating too much. Like, yes, you'll eventually have to, but I wouldn't stress over it. Anyway, so git apply, we probably want the check and verbose flags on it, and then we just put the name of the patch here. So check, what that's going to do is it's just going to dry run this rather than going ahead and applying it. So we can at least see like what's going to happen when we apply it. And in this case, we're going to have an error here, meaning we're going to have to resolve this error. Everything else applied successfully, so we don't need to worry about these. A hunk is just the like lines of code that are getting changed. So it's like, for example, at line 500 in dwm.c, we're going to remove this, add this. That's a hunk. So what we want to do now is change this check to reject here. And what reject is going to do is it's going to give us a file, config.def.h.rej there, that's going to have what it was not able to patch. So this is what we need to deal with manually. And we just need to remove this line and add this line. So this should be relatively easy to do. Just go into config.def.h here. It looked like this was at line 56 to 57, so we can go to line 56 there. And this is why it failed. This is a different line at line 56 than what this patch said was going to be there, right? So luckily this line is like a few lines down, so we can just paste in that new line and get rid of this old line. And then we should be good to go ahead and cleanly build this build of DWM now. So if I go ahead and just run make, it builds cleanly, we're good. And obviously with that particular patch, that was pretty easy to deal with, but like I said, as you're patching more and more patches in, it's gonna get harder and harder to the point where having some knowledge of how DWM actually works as a window manager can start to be very helpful. So one thing to note here, we're going to copy config.def.h to config.h when we're running make. So if you're going to remake this afterwards again, just remove config.h before you remake it. And in order to install it, it's just sudo make probably clean install, and you would just run that. That would install it. You can add exec dwm into your xinitrc file, and then just start x in order to start dwm. And that is how to patch DWM. So I think I pretty much went over what I wanted to go over here. You can get my build if you want to get it. I added, some stuff in the README that's necessary to know if you're going to use it, so you can read that if you want to. I've got the list of patches I used, etc. I'm sure I said something incorrect in this video, so feel free to correct me. The other thing I should say is all of the comments in dwm.c that I was sort of like looking at and reading through, I added the majority of those comments. The plain vanilla dwm.c does not have that level of comments, so if you want to go through something that has comments, you can check out my build, and I would actually welcome if somebody wants to pull request and either correct or add even more comments. That would be great, because I think having a version of dwm.c that somebody who does not know the C language could still read through and understand what's happening, that would be pretty cool. Anyways, this was a big video. I hope you enjoyed. I will see you next time. Peace!